Good morning, afternoon, evening, wherever you are. We are here from St. Andrew's Secondary School and we are going to present you our Problem X Challenge 2023. So this is what you'll be hearing from us today. So, here's the table of contents. Firstly, we are going to be introducing ourselves. Secondly, we will share the survey we conducted among our schoolmates. Then, we'll talk about some misconceptions the students have about hydrogen. Continuing on, we'll be talking about how it works. Next, what we recommend for the usage of hydrogen. Finally, in Singapore's context, let's introduce ourselves. I am Mario, this is Josh, and this is Casper, and the three of us are from St. Andrew's Secondary School. We conducted a short survey amongst our peers, and we are going to be showing you what some of those results are and what are some misconceptions that they have. Some of them will be quite interesting to talk to you about, like how hydrogen as an alternative fuel works and why we recommend it. Lastly, we are going to bring it to a local context. So first of all, our survey. So one of the first questions we asked was if using hydrogen as an alternative source was safe. Interestingly, the majority of students said that it was, but almost 40% of them still think that it is dangerous. For the second question, we asked if hydrogen is a source that works, and overwhelmingly a lot of them said yes, which is very encouraging. Using hydrogen as an alternative source is eco-friendly, and we're glad that most of our peers think that it is. We also asked if hydrogen is a renewable source of energy. Majority think it is, but only now some of them do not despite hydrogen's abundance. Josh will now take over for the next part.
Question 5. So this is a tick-in option that they think is applicable to hydrogen as a fuel source. The majority of them said that it was, followed by some ways that hydrogen is obtained. Almost all of them have heard of the 4 most common methods, and there is a small percentage of 17% who actually have not heard of any methods. These are some misconceptions among our peers. It will affect the environment. It is very interesting. It is dangerous. I think you're still remembering the history lesson of the Hindenburg. I don't know where that misconception comes from, even though hydrogen is so abundant in the air. It is difficult to handle. I think it was long ago, but maybe not now. Next, what do you think is released through the use of hydrogen? So some of them think that carbon monoxide, oxygen, carbon dioxide. All these are misconceptions that come from our peers. What do you think it is used for today? Perfume, preservation, and heating. What do you think are the dangers of using hydrogen? Only liquid hydrogen can freeze things rapidly as the temperature of it is extremely low. Hydrogen is an abundant element in the universe, so it will likely not run out. Hydrogen is a green fuel, so it wouldn't cause global warming. How would hydrogen cause floods? Now, we are going to talk about how hydrogen is obtained. There are 2 methods, electrolysis and natural gas reforming. So what is electrolysis? Electrolysis is a technique used by scientists to separate a compound or molecule into its component parts. By adding electricity to water and providing a path for the different particles to follow, the water can be separated into hydrogen and oxygen. Electrolysis is able to produce hydrogen using renewable energy. However, water with very small amounts of ions is a bad conductor of electricity, which makes electrolysis a very slow process. The second method is natural gas reforming. Natural gas reforming is an advanced and mature production process that builds upon the existing natural gas pipeline delivery infrastructure. Natural gas contains methane that can be used to produce hydrogen with thermal processes such as steam methane reformation and partial oxidation. So what is steam methane reformation? It is a mature production process in which high-temperature steam, 700 to 1000 degrees Celsius, is used to produce hydrogen from a methane source, such as natural gas. In steam methane reforming, methane reacts with steam under 3 to 25 bar pressure, 1 bar equals 14.5 psi, in the presence of a catalyst to produce hydrogen, carbon monoxide, and a relatively small amount of carbon dioxide. Steam reforming is endothermic, that is, heat must be supplied to the process for the reaction to proceed. In what is called the water-gas shift reaction, the carbon monoxide and steam are reacted using a catalyst to produce carbon dioxide and more hydrogen. In a final process step called pressure swing adsorption, carbon dioxide and other impurities are removed from the gas stream, leaving pure hydrogen. Steam reforming can also be used to produce hydrogen from other fuels. Here are the formulas. Now, I will be talking about partial oxidation. So, how does it work? In partial oxidation, the methane and other hydrocarbons in natural gas react with a limited amount of oxygen that is not enough to completely oxidize the hydrocarbons to carbon dioxide and water. With less than the stoichiometric amount of oxygen available, the reaction products contain primarily hydrogen and carbon monoxide, and a relatively small amount of carbon dioxide and other compounds. Subsequently, in a water-gas shift reaction, The carbon monoxide reacts with water to form carbon dioxide and more hydrogen. Partial oxidation is an exothermic process. The process is, typically, much faster than steam reforming and requires a smaller reactor vessel. As can be seen in chemical reactions of partial oxidation, this process initially produces less hydrogen per unit of the input fuel than is obtained by steam reforming of the same fuel. Here are the formulas. An advantage of natural gas reformation is that this reaction will produce the highest yield of hydrogen. However, it produces significant amounts of carbon dioxide as a byproduct. Now, we'll share our recommendations for the usage of hydrogen. Hydrogen is a green energy which can be safely used as an alternative fuel for cars, the generation of electricity, the production of fertilizers, and many more. This shows that hydrogen is a useful resource that we could utilize to reduce emissions of greenhouse gases. Next, Casper will talk about Singapore's context.
Singapore believes that low-carbon hydrogen has the potential to be a major decarbonization pathway to support our transition towards net zero by 2050. For Singapore, hydrogen will complement and diversify our power mix alongside solar, imported electricity, and other potential low-carbon energy sources. Thank you for listening to our presentation. We hope you have learned some things from this. Goodbye.